Hi, and welcome back to Activity B for your Star Spectra Gizmo. So you should have completed stars 1, 2, 3, and 4. So now we are going to start looking at stars 5 through 10. So we're going to follow the same procedure that we did for our other stars, except this time we're going to find that the spectra here behave a little bit different. There's something special, there's something different about these stars that we need to be on the lookout for. So let's look at star number 5 together. So I can complete that I know that this is a yellow star in color. And let's see if we can figure out which elements are in its spectrum. So we're going to start with neutral, and we'll drag down hydrogen. Let's see. Now I'm inclined to say that that's not a match. However, if I slide everything to the right, it is a match. So I think that hydrogen is a part of that star. All right, let's look at helium. No, and even if I slide things to the right, helium doesn't match up. All right, let's try sodium. Ooh, I think that this one could because of those double lines. Yes, so if I slide again everything to the right, sodium matches up. Interesting. So I'm going to write down hydrogen and sodium. I'm going to go through and just try my others, and I might slide them to the right and see if there's any matches. No. What about iron? Nope. Okay. So it looks like for hydrogen, when I slide things to the right, I get 1, 2, 3, 4 lines that match up. So then let's see if we can take care of the other ones with sodium. 1, 2, yes. Okay, so those are my 2 elements. So I can record that now. Hydrogen and sodium are my 2 elements. So what class is that? We're going to refer back to our chart. We have yellow in color, so it tells us that it should be G. Neutral sodium and calcium. We might have ionized calcium, ionized iron, or ionized magnesium. None of that really quite seems to fit. So let's try. We have hydrogen, ionized sodium or calcium, neutral sodium or calcium. Bingo, that's it. Because we had neutral hydrogen and we had neutral sodium. So even though my star may look yellow, it is actually going to fall into that F spectral class. So please record that. My unusual feature here with my spectra is that everything is shifted to the right. Notice that everything is shifted to the right. It's shifted towards the red. All right, so let's take another one. This one sounds interesting. Let's try 9. Whoa, are you all seeing what I'm seeing? Do you see these lines moving? Okay, so it looks like the lines are moving both towards and away from each other. All right, so let's start with color. It looks like this is a white star. Let's see what we can do to match up. So let's do hydrogen. We're going to match them end to end because things are all sorts of wonky and moving right now. So when they freeze in place, yes, hydrogen matches, and this one looks strangely familiar. This one looks a lot like my sodium from number 5. So I'm going to line this one back up end to end and wait for everything to settle into place and stop. And what do you notice? All right, so star number 9 also has hydrogen and sodium in it. So let's see which class we could have. We have a white star with hydrogen and sodium. Well, class A has hydrogen and ionized sodium. Class G has neutral sodium. So it really could be either an A or a G class. So we could put A, G or A/G there. So now what's this unusual feature for number 9? If you said the lines are moving, you're absolutely right, but let's be more specific. How are they moving? Are they all moving in one direction? Are they all moving away from each other and then back together? So it looks like these lines actually move back and forth in opposite directions. So let's record that on our lab sheet. So now you are going to work through stars 6, 7, 8, and 10 because we've done 5 and 9 together. Same procedure we've been following. Make sure that when you notice what's unusual that you record it and that you record good information about what you're seeing. Because down in the bottom, you have matching, where you are actually going to be able to figure out what is happening in stars 5 through 10 and why their spectra have such interesting features. So if we look at star number 5, I told you it shifted to the right. It shifted towards the red. So do you see something that says redshift? I do. So it says if a star is moving away from an observer, the spectral lines are redshifted or shifted towards the red end of the spectrum. An approaching star is blue shifted. So star number 5 is absolutely showing us a redshift, so I can write that on the line. I want you to solve the rest of them on your own.